So how do we use decision tree for classification? So remember, we used in decision tree, we create decision tree, right? We start with a variable, right? And then we create those different, decisions, right? So there's something called as, which we did not discuss in regression. I kept it. We took the default one, which we'll talk about now in classification. There's something called as criterion. Okay, which tells you which criteria should be used to um, divide or create that decision tree. Okay, so most popular ones are entropy and Gini index. We'll talk about them in some time, but let's understand the decision tree, right? Now, if you have here add success, right? So do you remember the data set for add success? Don't remember, right? So let me take you there. So GitHub supplements are of machine learning. Okay. So this is in machine learning. And fifth one, looking at the fifth add success. So you have age, estimated salary, and gender, right? So you start with some value for estimated salary. Okay, estimated salary equal to 50,000. Then what happens if it is less than 50,000? What happens if it is more than 50,000? Okay, and then you keep on creating those decisions, different decisions. In fact, we can display the decisions that our algorithm will create in Python. Okay, so I'll show you. Okay, the decisions that are created. Let's first build the model. So how do we build the model? From sklearn, the algorithm is your tree, right? Tree, and I'm going to say import decision tree classifier. Okay, done. Now, of course, here we have to create decision tree classifier. Okay, and if you do not want, you can delete all of them. Of course, these are not. It's metric. Okay, that is it, right? Look here. See how the decisions are created. Is it not very similar to what we had created in regression, right? So since we have done scaling, right, we have -3 to 3, and it found the first criteria here, maybe first, or this could be first, or bottom here could be first. Then from here, okay, this is less than this value, this is greater than this value. Okay, so that's created this different decisions. Okay, it has created different decisions. Okay, and this is what is done by decision tree. Okay, so now this is red area. In regression, if a new value falls in this area, if while we are doing the prediction, okay, if the value comes from red area, in regression, it would take the average of all the training data, correct? And then give the answer. Here, this is marked as red. So if a new value falls in this red area, it will be marked as red. If value falls in green area, it will be marked as green, which is 1, right? Green is 1, red is 0. Okay, so this is how you can actually use your decision tree algorithm. Now, okay, now if you want to see, okay, if you want to see the, um, if you want to see the decision, what I'll do here is, let me try to write few lines of code. So I'm saying show decision tree created, criterion created. A decision tree created, okay? You want to see the decision tree created with what values, okay? So you will have something called as, okay, so I'll say output equal to tree dot something called as export tree. No, we have not used tree, right? So we'll say sklearn dot tree, okay, dot export, okay, export text. Okay, so we'll export text of the classifier. Okay, and now you print this. So I'm going to say print output. Okay, so you will get the description in the text. Okay. Now, if you want to visualize it, you can visualize it. Okay, so I'm going to say, we anyway have matplotlib, so I'm going to say, okay, so I'm going to say, figure equal to, okay, plt dot figure, and you give the size that you want. Okay, so size, let's say I give 40 comma 60. Okay, okay, and now, okay, now we will create the tree. Okay, tree plot equal to sklearn dot tree dot you have plot. What happened? It's not coming. Plot tree. Okay, plot tree, and you give classifier. Okay, and then I'm going to say plt dot show. Okay, so you see this. Can you see this? So this is the first, from here, this is the first tree. So what it has done, it said feature 0. Feature 0 is the first column. So age, right? So age is less than equal to 4 point, so 0.45, sorry, 0.47, right? So if you go here, okay, you will create decision like, okay, age, and since the scaled value age greater than equal to 0.47, yes and no, right? And again, if you see in yes, okay, so in yes, it will alternate. Okay, feature 1, feature 0, 1, okay, 1, and then it says, okay, if feature is less than equal to 0.47, and then feature 1 is less than equal to 0.455, and again feature 1 is less than 0.18, then classify it as 0. If it is more than, see, opposite, see, it's the same level. Same level means it is yes and this is no. Yes means feature 1 less than 0.818, yes, then classify as 0. If it is more than 0.18, then again you're looking for one more feature, and then you're classifying as 0, right? So this is the decision tree that decision tree will create for us. And this is what we had done, okay, when we were doing the regression, right? Okay, so this is your decision tree. Okay, now if you want to visualize it, you can even see this. See, this is the decision tree. Okay. x of 0, that is first less than equal to 0.468, 0.47 it showed in the tree, right? If it is yes, then check for x1, okay, no, and since I have given small size, right, it's overlapping, but this is how it's creating different decision trees. Okay, so here you see x0. Okay, then you have Gini index. By default, it creates Gini index. What is Gini index? Okay, so now here look at, it's talking about 300 samples, the data set sample it has taken. Okay, it will take randomly. Okay, it doesn't have to take same number of value, right? And then you start with 300, and then out of 300, 211 goes this side. That means yes. Then you have only 89 samples on the greater than, where x of 0 is greater than 0.468. Out of, again, 211, you have x1 less than 0.184 is about 175, and greater than 0.184 is 36. So it keeps on creating it. Okay, so what criteria it uses? Okay, so there are two criteria. One is called Gini index. Okay, other is called information gain. Okay, information gain. So what is Gini index? How do you calculate Gini index? Okay, so I'll take one sample example. In Excel, I'll show you how Gini index is created, and same. Okay, it apply every step it applies. Okay, same thing. Okay, so let's say, okay, let me open an Excel. Okay, wait, yeah, okay. So let's say you have, let's say, we had here male, female, gender also, right? So you had gender. No, wait, hold on. There's something here, right? The categorical column. Gender, correct. Gender, age. Let me see if we can copy paste these values here. No, we can't. Okay. So we have gender, age, and salary. And let's say we'll buy or not, right? So what I'll do here, okay, for um, because see, it has to be gender has to convert it again into 1 or 0, right? Yes or no, like 1 or 0. So let's assume, because see, female F is first, F comes before M, right? So with respect to female, we are saying if female is there or not. Okay, so I'm going to say yes means female. Okay, no means male. Okay, let's say yes, yes, yes. Okay, no, and let's say yes. Okay, and now what I'll do is, okay, let's assume that this data is again, is is um, is scaled. Okay, so I'll use random between, and we'll put 10 comma 30. Okay, so 10 comma 30, just for some value, right? I want to show how Gini index is calculated, and let this be like yes, 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 no, 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 no. Okay. Okay. Now you see here on the first iteration when you do it, okay, first iteration when you run this, okay. So before Gini index is calculated, okay, we look at the sample weight. Okay, what is the sample weight? Since it is first time you're doing it, okay, sample weight is going to be same. So how many you have? 4, 5, 6, 7, 8. Okay, so it's going to be 1 by 8. Sample weight is, okay, I'll put 1 by 8 here. Math cells number. Okay, so 1 by 8. Because if you add all of them together, if you see, sum is 1, right? So total it has to be 100%. Okay, the sample weight I'm saying it is 0.13. All are equally important for the calculation. All are equally important. Now you calculate, okay, you calculate the Gini index. Okay, so how do you calculate Gini index? Let's assume, okay, we say that, okay, if you see here, how many male and how many female are there? Male, you see, female, okay, 2 plus 2. So 2, yes, yes, yes. Okay, okay, so till now it is yes is more, right? So we'll assume, okay, this is first assumption, first row assumption, first tree assumption is that if female or if gender equal to yes, okay, people buy. Okay, so this is, let's say, first assumption. Second assumption, if you look at, okay, and we'll come up with some kind of analysis. Okay, so if age is, okay, we'll take, somewhere in between, let's say 20 to 30, we said, right? We'll say 25. Okay, so if age is less than equal to 25, people buy. I'm making some assumption, okay? It's okay. And in salary also, we'll put if salary less than 25, people buy. Salary less than equal to, we'll put, okay? Okay, so now you see, we have to create these three values here. So we'll talk about first, okay, gender. Okay, now gender, okay, correct and incorrect. How many correct values you got and how many incorrect? Now, if I start with this, if gender equal to yes, people buy. How many correct and how many incorrect? Okay, now you see from gender perspective, what I say, okay, yes will be yes and no will be no, correct? So yes is yes, yes is yes. So I got it correct. 1, 1 I'll put. Okay. Now, okay. So here also, okay. Okay. So in gender also, okay. Here I have to put first one. What is the assumption? Yes for yes, something like that. Okay. And this is going to be your no, no for no, right? That means if it is male, they will not buy. Male will not buy. Okay, and female will buy. Okay, so how many correct and how many incorrect did you get it? So coming here. So so what I'll do, I'll put y1 1. Okay, and for no, I'll put cross to indicate correct or not. Okay, so let's see. So y1 1. Okay, and no. So this is incorrect. Okay, no. So first, okay. So these are all your yes, yes, right? These are all your yes. These are all down no. So here you see how many incorrect did we get? So we got 3 correct and 1 wrong, correct? This no is yes, right? So we got 3 correct and we got 1 wrong. Now for no, you see, so you expect n, right? And this is also 3y. That means, okay, you got only 1 correct and you got 3 wrong. Did you understand how I calculated? Right? So if you are saying that no means gender should be n, sorry, gender should be n, correct. Yes means gender should be y. Okay. So so based on that, all the yes, okay, there is 3 correct and 1 incorrect. And if all the no, you have 3 incorrect, 1 correct. Okay, this is step 1. Step 2 is now, okay, to calculate your index value. Okay, so index value is calculated based on, okay, how many you got it right and how many you got it wrong. So it is like, okay, 1 minus sigma of this whole square. Now if you look at this value, so we got 4 correct and 4 wrong. 4 correct and 4 wrong. So your value is here. Okay. Uh, so how many correct you got? 4 out of 8. Correct? You got 4 out of 8. Right? You got
Yes.
4 out of 8 for correct. Correct is 4 out of 8. 4 out of 8. And incorrect is also 4 out of 8. So the formula here is 1 minus your correct square, okay, plus your incorrect square. So Gini index, okay, Gini index we calculate. Okay, so when you say Gini index 1 minus, okay, and inside we have to add both together. So it is 4 by 8. 4 by 8. Okay, and this is multiplied. 4 by 8 is 0.05, right? So I'll directly put 0.5 into 0.5, and then you need to plus this. Okay, so now see, this is first for your knowledge. We don't have to do all this. Okay, the algorithm will do all these things for us. I'm just showing you what Gini index mean. Okay, now you can say here 4 by 8. 4 by 8, which is again 0.05, right? 0.05 into 0.5, okay, and you add them together. You get 0.5. You get Gini index as 0.5. Okay. Similarly, you have to calculate for age and salary. Okay. You have to calculate for age and salary. Okay. So, okay, you calculate gender in for 0.5. Okay. And age, again, you have to, so again, it will be like, yes and no. And in yes, how many? So yes, you are saying that people less than 25 years of age. Okay, so let's do for age, and then similarly you can do that for other things also, right? So let me do age first, and other things you can do. Okay, so looking at all yes, so these are your first 4. Here, what I'm saying, if people is less than 25, they will buy. So less than 25, correct 1, correct 2, correct 3. So 3 and 1, okay, 3 correct and 1 incorrect. And no, okay, look at no. So no means what? Age should be more than 25, right? 26 and plus. So here you get all incorrect, right? So you get correct 0, okay, incorrect 4, right? So Gini index here is going to be 1 minus 3 by 4, 0.75, right? 0.75 into 0.75 plus, this is 0 by 4, right? So 0, right? So your answer would be 1 minus this, which is 4375. Okay, so 4375 means you have got more incorrect. 0.5 means you have got, almost you got halfway. Okay, and if you get 0.43, that means, less than half means you have got it wrong. You should have taken the other ways. Then you'd have been more accurate. So this is how Gini index is. So lower Gini index means your the value that you are taking is not right. Okay, the value that you are starting to divide is not correct. you need to change it. So maybe in this case, if you just do reverse, probably it will be even better, right? So if you get zero, I mean, if you get Gini index 0, okay, it means that all elements belong to a opposite, like what you have assumed, it's opposite of that. You got all wrong. That's what zero index will mean. Okay. And best case is when you get it all right. When you get all right, it will be 1 by 1. 1 square is 1. And here also 1 square is 1. So 1 plus 1 is 2. 1 minus 2 is, that's the best case scenario, isn't it? Okay. So this decides whether, okay, how should value be divided? Okay. So this is how the algorithm knows whether it's doing correct job or incorrect job. Okay, so by default, when we do not give any value here, it is Gini index. Okay, if you want to give, you can give here decision tree. You can say criterion equal to Gini. I think this is how we give. Let's see if it, yes. Okay, so then it's going to use Gini index to classify, to create the trees here. Okay, clear? So decision tree, as we have discussed in regression, it's create decision tree. It picks one value. Okay, how, which value is picked? So that is decided by the criterion that you give. So if you give Gini, it will create Gini index of different values, and one that gives you the highest value, right? Okay, that is picked as the, dividing factor, and from there it starts dividing the different values. Okay.
Yes.
So your decision tree is done. Now the next one is random forest. What do we do in random forest? Create multiple decision trees, isn't it?
Mhm.
So it will create multiple decision trees, and you have to, okay, so here, of course, for, I will put this here. Okay, so from sklearn dot ensemble, okay, import random forest classifier. Okay, so now here also you can give, let's say, classifier equal to, okay, uh, uh, random forest classifier, and I have to give number of estimator, right? How many trees you want to create? I'll say 30, or let it be 39. Okay, and then your um, uh, you need to give criterion, right? Which criterion it should use to create decision tree, Gini index. And the number of decision trees, this is the one that you will. Okay, so this is for one, right? Okay, so yeah, this is your confusion matrix for random forest. So you see, accuracy is 0.88. Makes sense?
Yes.
Okay, so this is how we actually work. Now we have concept of boosting, bagging, okay, and boosting, bagging, and ensemble. Okay, so this is like you are running individual algorithms. You are running individual algorithms and getting it. Okay, now, okay, if you want to, okay, if you want to make your algorithm stronger, you want to make your algorithm stronger, and we'll discuss this tomorrow. And tomorrow we will hopefully we'll able to finish off our classification. Okay. So okay, so there are three ways to improve, okay, your algorithm. One is called boosting, other is called bagging, okay, and then ensemble. So if you see here for random forest, what did we use? We used ensemble. Okay, so what is ensemble? I told you briefly also, right? So ensemble algorithms are a collection of multiple algorithms. Okay, it is used to create multiple algorithms. Okay, so ensemble is a technique. It's a technique, okay, using which you can improve your performance or the accuracy of your model. Okay, you can improve accuracy of your model, right? Now, how do you increase the accuracy of your model? By doing something extra over the model, right? By doing something additional on top of the models that you have built. So ensemble talks about, okay, what you do extra on top of the model. What you do extra on top of the model. Okay, so for example, okay, in this case, what are we doing? We are running multiple algorithms only, multiple decision trees. But what extra are we doing on top of it? We are not, see, in previous example, we were dependent on only one decision tree. We were dependent on only one decision tree. Okay, but now we are not dependent on only one decision tree. Instead, we are running multiple decision tree, now 39 decision trees, and we're taking average of all this. Okay, so the advantage of decision tree, okay, advantage of decision tree, sorry, the advantage of ensemble is that you are running multiple algorithms to improve the performance of the algorithm. So okay, so if you talk about this one, in ensemble algorithms, okay, we run we don't believe one, right? So we run multiple algorithms to improve the performance of a given problem, okay, or business objective. So you can achieve this using two ways or three ways rather, okay. One is called boosting, other is called bagging, and then you call stacking. Okay. Okay. So when you are doing um uh, when you are doing random forest, we are doing stacking. Okay. That means, okay, so not stacking, sorry. We are doing boosting. Now, stacking is when you do same thing over different algorithms. That's called stacking. Okay. Boosting is when you run same algorithm. Same algorithm. Okay. Bagging is also when you run same algorithm. Okay. Okay. Here you take average of all. Here you take average of all. But here input, okay, varies based on weights. Okay. So I may be running decision tree only. Okay. But when you run the second decision tree, okay, you don't give same weightage to all the decision tree. See, uh, um, I given this example, right? Like, let's say you have been given 10 assignments to work on. So one of you will do the first. So one algorithm will first run, and then it will see the accuracy. If based on the accuracy, it will be given its weightage. So if the accuracy is higher, its weightage will be higher. If the accuracy goes down, its weightage will go down. If accuracy goes higher, its weightage goes up. So it's like, you have, let's say you have 10 students trying to solve 10 problems. Okay. The one who is, let's suppose, to be more intelligent, you will give more importance to that person in doing the assignment. Right? So here you measure the performance of each other algorithm. So okay, it's not a simple average. It's not a simple average. Okay. But when you talk about bagging, we do average of all. When we do stacking, average of all. But bagging, again, it's the same algorithms. Okay, so you run multiple decision trees and take average. But here you can run, okay, um, SVM, decision tree, okay, or k nearest neighbor, or logistic regression, not or, and basically, okay. And then you take average of all the algorithms and say, okay, these algorithms are giving, let's say one is giving you yes, yes, no, yes, 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 no, yes. Three is giving you yes, one is giving you no. So you will say, let me classify this as yes. So you are getting value. Now in regression, same concept in regression also. In regression, you will take, if one is giving you 100, 150, 120, and 180, you take average of all these four values and say, okay, this for this kind of input, this is the output. So same logic, okay, but the way the things are calculated is different in each of these. So we call them as ensemble algorithms. Okay, ensemble algorithm is to make your weaker algorithm stronger. Okay, something which cannot give you better result by running it once, we run multiple times. That's what ensemble, we run multiple times. So tomorrow when we meet, we'll talk about boosting. We'll take one example of boosting, which is called adapt boosting, which is again based on your decision tree only. Okay, so we'll see how boosting works. Okay, and again, this Gini index is calculated based on that. The inputs are taken. Okay, so again, adapt boosting concept is for both regression and classification, right? So we will see adapt boosting classifier and adapt boosting regressor. Okay, and maybe I'll give you some examples how this. See, we started with sample 8 one by 8 because first time we are doing it, we don't know. Okay, which one has higher weightage? So we started with 1 by 8. Okay, and then second round when you create, it will not be 1 by 8. It will depend upon the accuracy of the model that it has worked on. So the sample weight will keep on changing in every iteration. Okay, so you have bagging, Okay, you have boosting and you have stack. Okay, so boosting is different. Boosting is where each model will have different weights, but your bagging and stacking are same concept. Only difference is bagging says that every algorithm that you take should be same algorithm, but stacking says take different algorithms. Okay, you have to take different set of algorithms. Okay, so we'll talk about it tomorrow. We'll end it here for today and we'll
Yes.
see you tomorrow. Bye.
Yeah.